Hello class, this is section 2.7. So this is more of combining functions. So let's look at this section. It says suppose the rule for function f is add 1 and the rule for the function g is multiply by 2. How can we express these functions algebraically? Well, if you're adding 1, that means you're adding 1 to the variable x. And if you're multiplying by 2, that means you're multiplying the variable x by 2. And the composition of those two would be f of g of x. That just means that you're plugging this function into the f function. So you're going to replace this x with 2x. So this becomes 2x plus 1. And the opposite would be to do g of f of x. That means you're going to do the reverse. That means you're going to substitute the f function into the g function. That means you're going to replace this x with x plus 1. So that would be 2 quantity x plus 1, or 2 times the quantity of x plus 1. And you could distribute if you'd like, or I think WebAssign would accept it the way it is without distributing, but I'm just going to go ahead and distribute. All right. For these next problems here, they're asking us to find the sum of those two functions, the difference and the product and the quotient, and their domains. So for all four of those combination of functions, the domain will always be the intersection of the domains of a and b. So you'll see what that means. So when we add these two functions together, we have 3 minus x squared plus x squared minus 4. These cancel, and you're left with negative 1. So that would just be negative 1. And the domain of this function is all real numbers because there's no restrictions on what x can be. X can be anything. You're not going to get undefined because there's no fraction. You're not going to get not a real number because there's no radicals. So those are the two only things you really need to worry about is denominators and radicals. In this case, there are neither. So there's no restrictions on what x can be. Any real number, same with this. So therefore, the domain is all real numbers. The difference would be 3 minus x squared minus, you've got to make sure that you put the g function in parentheses because we're going to have to distribute that subtraction. Then you can combine like terms. That's going to become negative 2x squared plus 7. And same thing, the domain is going to be all real numbers for both functions. So that means that it's all real numbers again. All right, the next, this is based off of the same two functions. So now we're finding the product of the two functions. So let's look at the product. So the first function was 3 minus x squared times the g function is x squared minus 4. So when you expand that out, you should get 3x squared minus 12 minus x to the 4th plus 4x squared. So combining like functions will give us negative x to the 4th plus 7x squared minus 12. And same thing, there's two polynomials. Whenever you're dealing with polynomials, the domain is going to be all real numbers. And finally, the quotient is going to be the f function divided by the g function. And there's really nothing you can simplify here. You could factor the denominator, but that's not going to help us out in any way. So I would just leave it the way it is. And the domain will be all real numbers, except there is an exception in this case. Because we have a fraction, you can't have the denominator equal to 0. So you would want to factor this for the sake of figuring out what the domain should exclude. In this case, the domain should exclude negative 2 and positive 2. So we're going to say all real numbers except those two values. And the way you can write that in interval notation would be negative infinity to negative 2 union negative 2 to positive 2 union positive 2 to infinity. That's how you would write all real numbers except negative 2 and positive 2. All right, for this problem, similarly, we just separate these two functions and find the domain of each one separately. The domain of this one would be all positive values, and the domain of this one would be, well, we have to remember to set it greater than or equal to 0, solve for x, reverse the direction. When you reverse the x and the y, that means the inequality will also flip. And so now you have two domains that you need to be concerned with, 0 and 1. For 0, notice that it's all the positive values. And for 1, it's all the values that are less than or equal to 1. And so the overlap is what the domain of the function is, and that's going to be 0 to 1, inclusive on both sides. The next problem asks for domain once again. So let's deal with the denominator first. You can't have x equal to 2, because if x is equal to 2, then you're going to get undefined. 2 minus 2 is 0. So first thing you should do is check the denominator, set it equal to 0, and solve. And you will get x equals positive 2, so that means that should be excluded from the domain. You also need the radical, everything under a radical to be positive, so you have to set that greater than or equal to 0. And you will get negative 9. So the domain will be all the values that are not equal to 2, so open circle at 2, and they have to be greater than or equal to negative 9. And you just have to jump over that hole there. So you could state the domain as everything from negative 9 to positive 2, excluding positive 2, union positive 2 to infinity. Here we have composition of two functions. In this case, we have f of x. That means we're going to substitute the f function into itself. So 3x minus 4 is going to replace the x. So we're going to have something that looks like this. 3 instead of x. You rewrite the f function instead of the x, and you still have that minus 4 after that. Then you want to distribute and combine like terms. Which is 9x minus 16. All right, the next one is very similar. It's just a g function, g of x. So this time you're going to do the same thing, but this time you're going to plug the g function into itself, replace that x with 2 minus x squared. So that would look like this, 2 minus x, replace the x, sorry. So you can just leave this open and replace what would have been an x with the g function, 2 minus x squared. And then here I would expand this out. When you expand that out, that should be 4. That's going to be 4. That's going to be negative 2x squared, negative 2x squared. So that's going to be negative 4x squared plus x to the 4th. Then you want to distribute and combine like terms. So our final answer would be negative x to the 4th plus 4x squared minus 2. Okay, and that pretty much does it. That's the same page. That concludes the second.